This will be a video discussing the electrical components on a typical Forrest manufacturing bandsaw. This applies to our simpler, less complicated machines where we basically just have a motor and a starter, but I'll explain to you what that means. My smaller saws, for example, this is a model 230, but my smaller saws have what we call a point of use operation. So I've got a start-stop button right here. Sometimes we may also have a start-stop button on the traveling table, but operator starts and stops the saw to run it, and there's not much more to it than that. But it starts with a motor. We have down here on this machine a 1 1/2 horsepower single phase brake motor. The brake motor is an important consideration for us. That means basically that the motor includes an internal brake to stop it. When the machine is not running, you can't turn the wheels because the motor brake is engaged. The way the brake works, it has a spring that pushes the brake pads together, stops the motor. Stops it really quick, like a second and a half. Quick demo. I don't know if you can, well, you can watch the wheel. Start it, spins up. When it hits stop, stops. Second and a half, maybe 2 seconds. Close enough to instantaneous. The idea here is that we don't want this machine, after the operator presses stop, we don't want the machine to be silently spinning down, coasting down. So the operator thinks that he's hit the stop button. It's actually still spinning. He goes in to reach the workpiece, whatever, off comes his finger. We don't want that. So the brake motor is a safety feature. So it's got a spring that applies it, and it has an electrical release, basically an electromagnet. Anytime the motor has power, the brake release electromagnet will also have power and pull the brake off. Basically compress the spring so that it can spin freely. There is also a manual brake release. So different motors have different styles. Some will have a knob right here on the back face, so you can turn it 90 degrees to release the brake. This one has, for lack of a better word, it has a stick. You probably can't see it right here, but on top of the motor is a little stick. Flip it over, and now that releases the brake, and I can spin the wheels by hand. The brake will auto reset. So if I now start the saw and stop it, the brake has been reset. So I can't spin the wheel manually again, and it just stops automatically. So the brake release only lasts as long as until you run the saw again. So that's your motor. Brake motor, spring apply, magnetic release, releases anytime the motor is running or when you manually release it until you turn the saw on again. The motor is wired to what's called a motor starter. This is a real common piece of industrial machinery. It does what the name would imply. It allows the motor to start. It does two things built in here. It has a pair of, or a set of contacts that pull together or close to allow power to go to the motor or not. And it has an overload, which is basically think of it as a circuit breaker or a fuse, but it's easily resettable. If for whatever reason the motor draws more amps than is allowed, risking burning up the motor, the overload will trip. The special part about all this, this is called a magnetic motor starter, because again, the starter contacts are pulled in by an electromagnet. So when I'm hitting the start button, what I'm actually doing is energizing the electromagnet, pulls the coils together, passes current, the motor can spin. When I hit the stop button, I'm breaking that circuit, the electrical circuit. Motor stops going, power stops going to the motor. The brake no longer sees power. It stops, the motor stops. What do you expect? The overload is also wired in with a contactor, such that when the overload trips, the contactor opens up, everything stops. We do ship these things with the overload set to automatic reset, so when everything cools down, you can start again, but it will not start again until you press the start button. If your building has a power outage, say you're over here working your building has a power outage. We're in Texas, so apparently we do that a lot here. We lose power for no good reason. If you lose power, obviously the saw's going to start, but that'll release the magnetic contactor. When the power comes back on in the building, it's not just going to start running again. Like if you had a light switch on here. If you have the light switch on, you're running the machine, power goes out, it stops. If you're using a light switch, the power comes back on in the building, the machine will start running again, whether you're there at it or not, whether you're safe or not. So as a safety feature, the magnetic starter, you lose power, everything stops, the power comes back on, the machine does not start again until you push the start button, and everything else is good. We do not provide a disconnect. So depending on where you are, your local building codes, electrical codes, whatever, you may be required, probably are required, to have some form of disconnect. Typically, what you'll do is you'll mount a disconnect on the wall, visible from the operation point of the machine, and that'll be a disconnect. And you'll run wire in hard conduit from the start box up, over, down to the disconnect, and that's your way to disconnect the machine from power. Some municipalities may require that to be a fused disconnect. A third option, and a lot of my customers do this, whether it's code or not, what they'll do is they will have a flexible cord. So we're using a flexible cord to power this thing right now just because I don't know how the customer's going to want to connect this up, and I'm not going to poke out any of the holes here. So we use a temporary flexible cord, but you can have a permanent flexible cord running to a plug in the wall behind you where you can't see it. To disconnect the machine, I can just pull the plug out. The machine is disconnected, it's safe to operate on. This machine right now, since you just saw it running, the disconnect is closed, i.e. power is going to the starter. I hit the start button, it can run. A few more notes. We ship machines with single phase and 3-phase motors. This machine is single phase. We have 1 horsepower, 1.5 horsepower, and 2 horsepower motors. On our smaller saws, we do 3 horsepower, 5 horsepower, 10 horsepower motors on our bigger machines, but those usually get special controls. Smaller machine like this, we're either going to run in single phase or 3-phase power. This machine is set up for single phase power. I have different types of starters depending on what's available. I used to use Square D, they're hard to get now, or Telemechanique, they're hard to get. This is a WEG, W-E-G style starter. It's what we've been using for the past few years. They work great, haven't had any problems with them. I have a specific manual for what to do with these starters, how to wire them up, what to put where. In general, I'm not saying do this unless you are a qualified electrician or otherwise safe to use, work with electrical systems and controls. But for you electricians, here's the overview. This is obviously a multimeter. All these machines run on AC power, so I have my multimeter set on the voltage reading setting. Yeah, I'll help you with this. Is that going to focus? Yeah. V with a squiggly line, alternating current voltage. I'm going to confirm my incoming power is the correct voltage. So please look at the manual to do this, but on the WEG style starters, the terminals marked 1L1 and 3L2. 1L1 and 3L2 are the incoming AC power. And so I put my probes across there, and I'm reading 212 volts. 212 volts. This particular motor is a nominal 115, 230 volt motor. It is also operable on 208 volts. The reality is 208 volts is not reliable. I strongly recommend against running 208 volts. Anytime I have problems with one of my machines, it's a 208 volt machine. Please run either 115 or 230 volts. You can run 208 volts, it's iffier. So I know I have the correct incoming power. On the bottom, the connections for this type of starter, the WEG type starter going to the motor, are marked. Where are they marked? 2T1 and 4T2. It's the middle and left contact down here. 2T1, 4T2. And please don't shock yourself doing this. So when I turn the motor on, the voltage in this case temporarily dropped as low as 175, and now I'm pulling 208 volts. So with the motor running, I'm pulling 208 volts. In electrical terms, we have what's called a line loss or amperage drop or voltage drop. Between the plug and the actual motor, we lose volts when the thing's running. When we're not running, it's 212. When we're running, it's 208. 208 is the bare minimum volts you want to run this thing on. If your volts drop below 208 volts, you really need a transformer to increase your voltage. But checking the voltage here and here, the incoming voltage, the outgoing voltage, make sure that you have the correct operating voltage for the machine. If it drops too low, you burn out your motor. For example, I know for a fact, if your voltage drops to 200 volt while you're running, the motor's going to burn out. The brake coil electromagnet is going to burn out. So don't do that. It's just worth knowing what is your incoming voltage and what is your running voltage. So again, we use different starters. This is the WEG style starter, WEG. We have manuals for this and all the other starters we've used historically, or if you have a machine with more sophisticated controls, we have manuals for those as well. But those are the basic electrical components of most Forrest operator-attended bandsaws. If you have any questions or like to discuss a specific application for our saws, please feel free to call or email us. Thank you.